So I have demonstrated the CSMA CD protocol, which is the Carrier Sense Multiple Access Collision Detection Protocol. What basically happens here, suppose there's a node 1 that is sending data to node 22. So what happens is, initially node 1 will sense its transmission link. If it is idle, if it is, then it will send the data to node 22. But if in how do we know if it's idle? If there's no collision signal detected. If there was a collision happening anywhere along the way because another node decided to transmit data at the same time, there will be a collision signal sent across all the stations. So that is, a jam signal will be sent on the link, and therefore the nodes will have to wait for a random the node will waits for a random time interval before sensing the link again and then sending the data. So it's like wait for data and transmit data and then check for collisions. So what did I do here? I basically made a bus configuration. That is basically, you use rapid configuration, the bus topology. I clicked on next. Then I selected a model. This is ETH-COAX. ETH-COAX station was the node model, that is these. Then Ethernet coax is this Ethernet bus that connects the nodes to each other. Basically these nodes are connected through an Ethernet tap, which is a bus tab that will just connect your nodes to the bus. This just connects it to the bus receiver transmitters and nodes to the bus transmitters and receivers. The Ethernet coaxial basically through the taps. So these were done, and then I said okay, but I've already done that, so I don't want to change it. Now what happens is I chose to reconfigure our link. So you select edit attributes advanced. Here I chose the delay to be 0.5. It's a higher delay is basically used as an alternative to generating more traffic, which would basically need more simulation time. And thickness was to just mention the thickness of the line, the thickness of the bus. It's for aesthetic purposes here. After that, even the model that we use is an Ethernet coaxial advanced model. After that, so this is how the bus topology would look. Then now, what have I done is I chose to edit the attributes. In traffic generation parameters, we use that is on state time. In the on state, packets are sent. The off state is just a short one. Here the exponential distribution, as for this is the distribution, it's basically the mean of the interval between successive events. That's what it calculates. It's basically the probability of the occurrence of the next event is not dependent on basically what time the last event occurred or how much time has passed since that event. Yeah, after that I also configured packet generation arguments. Basically constant and promoted is, it just allows us to work with different loads. It just assigns multiple values to the inter-arrival time attribute so that it keeps changing. That's what I've done. So yeah. Next is I had to run, before running the simulation, I chose first the individual statistics I've chosen. Within global, I've chosen the traffic sync, that is the traffic received, which is by packets per second by all the syncs across the nodes. And all the sources sending the traffic sent by the traffic sources across all the nodes. And then you even choose statistics in advance. like advanced statistics. So what have I done is I wanted in scalar so that I can measure it properly, and I don't need direction in this case. So scalar data enabled. Scalar type though, I've decided to calculate the average over time, the time average, because we're using the mean anyway for exponential distribution. So it makes sense. It's the same for sense. I won't be showing that. So I ran this simulation. I will be showing the results for about 15 seconds. View results. So as these are the two graphs. This is traffic received. As you can see, initially there weren't much packets being received per se, packets received by the sinks, because we were at the very beginning where there was a huge spike in traffic packets being sent, as you know, because all the nodes had detected that that the load must have been heavy and the inter-arrival times must have been short. So like there were these, what is inter-arrival time? Actually, it's the time between successive packet generations in the on states. So there was a spike in that because all the load must have been heavy initially. So there's a big spike, and then it the inter-arrival time would change as it started becoming, less. It must have been less. Therefore, a lot of packets were generated initially. Then they kept change. Then it fell for a while, and then it started like changing all the time. Whereas the packets received will always be, see, it started off low because there were collisions happening, because of the collisions happening initially, because of so many packets being sent. Then later on, you see it's a little, it has increased, the packets received. As you know, there were these, because the inter-arrival times also became changed rapidly, were also changed. So the load also is like a little different. It kind of also puts like a variety of loads onto our network, onto this layout. That's what happened, and that is how the received packets are increasing, because the load started dropping. So the number of packets, the inter-arrival time was also changing. So there were like an increase in the packets being sent, then a drop in the packets being sent, because already by that time there were collisions that had happened. So the nodes that wanted to send would have been waiting for the next, for a random amount of time. That's what happened, and these are the graphs. So that's it.